Welcome to 1.5, Continuity. Continuity is the noun for the adjective continuous. Continuous means it keeps going. In math, this is an example of a continuous line. It just keeps going. We don't take breaks. And here is a line that is not continuous. Not continuous. We say there is a discontinuity. Continuous, not continuous. I mean, this is pretty intuitive, it makes sense, but in math, we want to know how to know for certain something is continuous or not continuous. Well, here are some examples of functions that are not continuous at some points. Here's the first example. This function looks like y equals x squared, except when x equals 2, y is not 4. Y is actually 1. Okay? That's why when the function gets to x equals 2, there is this hollow circle at 2, 4, because the function is not there. Instead, the function is at 2, 1, this point. The left-hand limit the function as it approaches from the left-hand side, well, is approaching the number y equals 4. So the left-hand limit is 4. The right-hand limit, the function as it approaches from the right-hand side, well, when we follow the function, is also approaching y equals 4. So the right-hand limit is also equal to 4. So the left-hand limit is equal to the right-hand limit. But they're not equal to the function at x equals 2, because at x equals 2, the function is at 1. When this happens, left-hand limit equals right-hand limit, but does not equal to the function, we have what is called a removable discontinuity. Okay. Continuity. Remove means to take out, and we just took out this point and put it somewhere else. Next, let's look at a different type of discontinuity. This time we have a graph. When x is less than 2, it looks like y equals negative x squared plus 3. And when x is greater than 2, or equal to 2, it looks like y equals x. Well, the left-hand limit comes from the left-hand side. What is the graph approaching? The left-hand limit, when we follow the function from the left-hand side, is approaching the number negative 1. So the left-hand limit is negative 1. The right-hand limit, same function, but we're coming in from the right-hand side. The right-hand limit is approaching a different number, 2. So the right-hand limit is equal to 2. When the left-hand limit and the right-hand limit are different, they both exist. We have a left-hand limit and we have a right-hand limit, but they're different. When that happens, we have what is called a jump discontinuity. Okay. What is a jump? Well, let's go to Google Images, jump, and here's an example of someone jumping. And this graph jumped when x gets to 2. It just jumps over here. The left-hand limit and right-hand limit both exist, but they are not different. So this is called a jump discontinuity. One more type, final type. This is the graph of f of x is equal to 1 over x minus 2. From the left-hand side, this goes to negative infinity, which is not a number, but it's going towards negative infinity. From the right-hand side, it's going towards positive infinity. So the right-hand side is going towards positive infinity. From the left-hand side, is going towards negative infinity. When that happens, we can draw this. This is called an asymptote. And the name of this discontinuity, this is called a vertical asymptote. Vertical means up, down. Okay. So this line is called a vertical asymptote. And it's not continuous because the graph is getting smaller and smaller and smaller and smaller. It goes to negative infinity. And then jump! And it comes here from positive infinity. When that happens, it's called an asymptote. So we have looked at three types of discontinuity: removable, jump, and vertical asymptote. Okay. So here are the three types. With removable discontinuities, the left-hand limit and the right-hand limit are equal, but they're different from f of x. With jump discontinuities, the left-hand limit and the right-hand limits are not the same. With vertical asymptotes, the function is approaching plus or minus infinity. Technically, limits don't actually exist because infinity is not a number, but the idea is that we can describe it by saying that it's going to positive or negative infinity, and it's discontinuous. And no matter what, the left-hand limit is certainly not equal to the right-hand limit. Okay. So mathematicians want to be more rigorous. They want to say, I want a definition of continuity. Okay, like in English, we might learn that the definition of the word outstanding, while Google is giving us, prominent, conspicuous, striking, that's the definition of outstanding. In math, we want a definition of continuity. How do we know when something is continuous? Well, let's look at one type of discontinuity, the removable ones. When we might have a removable discontinuity, what's the only difference between the removable discontinuity and a continuous function is that there's some point where f of x is not equal to the limit. The limit exists, but it's not equal to the function. In the discontinuous case, the left-hand limit here is equal to 4. The right-hand limit is equal to 4, but the function is not equal to 4. Whereas for continuous functions, the left-hand limit is equal to 4, the right-hand limit is equal to 4, and the function is equal to 4 when x equals 2. So here's the definition of continuity. F of x is continuous at x equals c. I want to be more rigorous. If the limit of f of x as x approaches c is equal to f of c. In other words, f is continuous when the limit is equal to the function. Sometimes, like with a jump discontinuity, the limit doesn't exist because the left-hand limit and the right-hand limit are different. So it's discontinuous. Sometimes the limit exists, but it's different from the function itself. So it's also discontinuous. Okay, let's look at two examples. Let's look at actually a few examples. Example 1. F of x is equal to, when x is less than or equal to 4, 2x minus 3. And when x is greater than 4, x plus 1. This is called a piecewise function. Is f of x continuous at x equals 4? Okay. When we answer that question, we want to look at the left-hand limit the right-hand limit and the function itself. If not, what type of discontinuity we have? Well, f of x is continuous if the left-hand limit and the right-hand limit are equal to f of 4. The left-hand limit, that's easy, we can just plug in. 2 times 4 minus 3 is 5. The right-hand limit, we can just plug in. 4 plus 1 is equal to 5. They're the same, that's a good sign. The function is also 2 times 4 minus 3 is equal to 5. We use 2x minus 3 because the function says for x is less than or equal to 4, we use 2x minus 3. Because the left-hand limit, the right-hand limit, and the function are all equal, we say yes, f of x is continuous at x equals 4. Next one, example 2. F of x is equal to, when x is less than or equal to 1, f of x is equal to 2x minus 2. When x is greater than 1, f of x is x plus 2. Is f of x continuous at x equals 1? If not, what type of discontinuity do we have? Same question as before, different function. Okay. Again, it's continuous if the left-hand limit is equal to the right-hand limit is equal to the function. The left-hand limit we plug in is 2 times 1 minus 2, which is 0. The right-hand limit we plug in is 2 plus 2 equals 4. They are not equal. Because the left-hand limit and the right-hand limit are different, no, it is not continuous at x equals 1. And when they're different, and we have both the left-hand limit and the right-hand limit, but they're different, so we have a jump discontinuity. Example 3, final example. F of x, well, is equal to x, except when x is equal to 2, f of x is equal to 3. The graph actually looks like this. Here are axes. Normally, it just looks like f of x equals to x. Except that when x is equal to 2, it's not equal to here. Instead, we're told that it's equal to 3. Because this is 2, this is 3. Okay? So you should be able to see that this is not continuous. Let's prove it. Well, again, f of x is continuous if left-hand limit equals right-hand limit equals the function. The left-hand limit and the right-hand limit are both 2, but the function is at 3. When that happens, it is not continuous, and we have a removable discontinuity because the left-hand limit and the right-hand limit are the same. And the limit, so there is a limit to this function at x equals 2, but it's different from the value of the function itself. Okay? So that's it for continuity.